Part A states, use the comparison theorem found on page 525 of your text to show the divergence of the improper integral from 1 to infinity of 1 over x times square root of 1 plus 1 over x to the fourth dx. Question B states, let f of x equal 1 over x. Denote R to be the region between the graph of f and the x-axis 1 to infinity. Let S be the horn generated by revolving R around the x-axis. Can you fill the horn with 3 cubic units of paint? If not, how much paint is needed if it's at all possible? For question C, show that there isn't enough semi-gloss enamel on the whole planet to paint the surface of the horn, but of course you can dig up enough paint to cover the surface of the horn from x equals 1 to x equals 5. Roughly how much paint will you need?
Part A asks us to use the comparison test to prove that the integral from 1 to infinity of a sub n is divergent, where a sub n equals 1 over x times the square root of 1 plus 1 over x to the fourth. The comparison test is used for a series, not an integral, but the given integral is the integral test for the summation of a sub n. So we can use the comparison test on the summation. We want to prove that a sub n is divergent, so we have to compare it to a smaller divergent function. Looking at a sub n, the beginning of it is 1 over n, a divergent harmonic series. So we can leave 1 over n alone and focus on the square root. We can see that the smallest value the square root can be is 1, no matter what number you enter in for n, which means the smallest value a sub n can be is 1 over n. We can compare a sub n to the divergent harmonic series 1 over n. Since a sub n is greater than or equal to a divergent series 1 over n, a sub n must also diverge, which means that the summation is also divergent, and same goes for the given integral.
Part B. Let f of x equal 1 over x. Denote R to be the region between the graph of f and the x-axis on 1 to infinity. Let S be the horn generated by revolving R around the x-axis. Can you fill the horn with 3 cubic units of paint? If not, how much paint is needed if it's at all possible? In this question, we need to find out if 3 cubic units of paint will be enough to fill the horn of the graph. We were given that f of x equals 1 over x is rotated around the x-axis. Since the question uses cubic units, that means we are calculating the volume. To solve this problem, we first need to graph the curve f of x equals 1 over x and rotate it around the x-axis. As you can see, the red line shows a graph of f of x is equal to 1 over x. The blue line shows a shape made after rotating it around the x-axis. This shape makes up the horn. On the right, we can see a 3D representation of the horn. This is Gabriel's horn. Gabriel's horn is a geometric shape that has an infinite surface area but a finite volume. So to find the volume, we need to take the integral of f of x equals 1 over x to see if it diverges or converges. If it converges, we have to see if the number it converges to is greater than or less than 3. The integral is pi times the integral from 1 to infinity of 1 over x squared dx. First, we have to take the limit and then solve the integral. We take the limit as t approaches infinity of pi times the integral of 1 to t of 1 over x squared dx. We can simplify this integral by distributing the 2 to the numerator and denominator. After it's simplified, we get the limit as t approaches infinity of pi times the integral of 1 to t of 1 over x squared dx. After solving the integral, we get negative 1 over x. So now we find the limit as t approaches infinity of pi times negative 1 over x from 1 to t. We can now plug in the bounds. So we have the limit as t approaches infinity of pi times negative 1 over t plus 1 over 1. After solving and simplifying this, we get pi. We know pi is about 3.14. From this we know about 3 cubic units of paint will not be enough paint to fill the horn, but 3.14 cubic units of paint will be.
Part C's problem says, show that there isn't enough semi-gloss enamel on the whole planet to paint the surface of the horn. But of course you can dig up enough paint to cover the surface of the horn from x equals 1 to x equals 5. Roughly how much paint will you need? This part of the problem is asking us to show that the surface area is infinite, yet it is finite from 1 to 5. The equation for finding the surface area is shown below. And now let's begin a solution for part C. To show that there is not enough semi-gloss enamel on the whole planet to paint the surface of the horn, our bounds will be from 1 to infinity. Although for this next part, you will see our bounds are from 1 to 5. All that is left is to find R, which was given in part A. So to show that there is not enough semi-gloss enamel on the whole planet to paint the surface of the horn, we use the following integral and solve. In part A, we found that this integral from 1 to infinity is divergent. Multiplying a divergent series and multiplying it by 2 pi does not change it. Therefore, the series still diverges. Now, to show that you can dig up enough paint to cover the surface of the horn from x equals 1 to x equals 5, we will use the following integral and solve.
So now we have to take the equation of the area and simplify it. We can do this by under the radical. We can get common denominators with x to the fourth. Once you do that, it becomes x to the fourth plus 1 in the numerator all over x to the fourth. Now you can split up the square root, being square root x to the fourth plus 1 all over x squared. So now you can multiply by the 1 over x to get x to the third, which is shown here. Now we can use integration to help solve this integral. We use u as the square root of x to the fourth plus 1 and choose dv to be 1 over x cubed. Then we find du by taking the derivative of u, becoming x squared to the third over square root x to the fourth plus 1. And v, to find v, we take the integral of 1 over x to the third, which is negative 1 over 2x squared. Now we can put it into the equation for integration by parts, being u times v minus the integral from 5 to 1 of v du. Now we can simplify this integral by canceling out the 2x cubed on the top and 2x squared on the bottom, leaving us a negative x on top. Now we can pull the negative 1 out to make it a plus the integral. Now that we simplified it, we can use another u substitution, making u equals x squared, du to equal 2x dx. Then we can help solve by dividing the 2 over to the du and inputting it into the equation, getting now the integral from 1 to 5, 1 over root u squared plus 1 du. From here we can solve the integral by making it ln the absolute value of square root u squared plus 1 plus u. Now we plug in the bounds and then solve. Once you crunch this out, you get approximately 10.82090.
For these problems, we need to know a few different concepts. For part A, we use the harmonic series, which only tests divergence, and compared our original equation with 1 over n. Our final answer is the series diverges because of the harmonic series. For question B, we learned a new concept called Gabriel's horn, which is a geometric shape that has infinite surface area but finite volume. We had the integral from 1 to t of pi times 1 over x squared dx and got the final answer as pi. Since pi is 3.14, 3 cans of paint will not be enough. For part C, we use the volume equation, the integral from alpha to beta 2 pi r, where alpha to beta is 1 to 5, and r is f of x times square root of 1 plus f prime of x squared, and our f of x is 1 over x, so we can plug in 1 over x into all the f of x's. To solve the integral, we use IBP and basic U substitution, and ending our answer with roughly 10.82.